Hi, in this video, I will show you how to use RESNets code to predict a brain network evolution trajectory from a single observation. This work is published and selected as oral presentation at Prime Workshop held in MICCAI Conference 2020. In order to start using RESNets, we first need to download TensorFlow and other packages. Then we can start the execution of our framework. First, you need to install TensorFlow using this command. I installed TensorFlow version 1.5 for Python 3. You also need to install Jupyter Notebook, NumPy, scikit-learn, and SciPy packages. To do so, you can use given commands. Next, we install our RESNets code from our GitHub profile. First of all, in order to use our framework, you need to use feature vectors, which are flattened version of brain networks. Therefore, first you have your brain networks NR by NR. NR denotes the number of region of interests. Then, you vectorize them into vectors which have the length of NF calculated by given formula. At the end, you have your feature vectors which can be used in RESNets. Now, let's take a look at parameters of RESNets. Firstly, we have a testing subject which wants to come up with its brain evolution trajectory. Secondly, baseline feature vectors, among which RESNets will select k of them, which is a hyperparameter. Then, longitudinal feature vectors should be passed. As we said earlier, hyperparameter k should be passed. And lastly, number of regions of interest should be supplied in order to RESNets work consistently. We feed all of these parameters to RESNets, and at the end it produces prediction of evolution trajectory of testing subject for each time point. Once you installed the dependencies, now I can explain how to run RESNets on your computer. Firstly, use your terminal to open Jupyter Notebook in your browser. Secondly, go to the folder you downloaded and click Inside. After that, open a Python 3 notebook and type run demo.py and run it. It will ask you questions about the dataset which it will simulate. After supplying the inputs, wait for its execution to end. Finally, it will output the embedding loss of brain networks, and it will visualize the testing subject at baseline time point and other predicted time points. For more details, you can check our YouTube video on our Basira Lab channel, and you can check our code on GitHub by clicking the link down below.